Hello and welcome to this recorded e-learning on Basic FPGA Configuration Part 2. My name is Frank Nelson. I'll be your instructor for this module. This module is intended to continue your learning opportunity about FPGA configuration so that you can choose the appropriate configuration scheme that best supports your application. Please note, if you have not had a chance to listen to Part 1, you may want to check it out before listening to this recording. If you're an experienced ASIC designer or new to FPGA design, this module will help you reduce your learning curve and get productive faster with your new FPGA design. This module will help you understand the configuration process. The configuration principles and design practices I'm about to describe apply to virtually all Xilinx devices. After completing this module, you'll be able to answer some frequently asked questions. You'll be able to describe the prototyping hardware we currently provide, explain the role of each phase of the configuration sequence, identify how to connect multiple FPGAs into a configuration daisy chain. This will allow you to configure a device from a single PROM. And you'll be able to describe the features of the Xilinx Platform Flash and the Platform Flash XL devices. My first question is, should my FPGA load its configuration data from an external memory resource, or should a processor or microcontroller download the configuration data? Well, the benefit of slave configuration modes is that the bit stream can be stored pretty much anywhere in your hardware system. You can store your bit stream on a flash, laptop, hard disk, or somewhere on the network if you so desire. Your system can basically be whatever you're willing to build. In fact, many customers will build their control logic to also support more than one configuration scheme, especially in the case when they're trying to support in-system delivery of FPGA updates through the JTAG chain. While this complicates the construction of the control logic, because of course it has to be done manually by yourself, by supporting JTAG as well, it does allow debugging the system at any time. The caveat associated with slave configuration schemes is that you'll have to purchase additional components or plan for the additional logic to be built. And this might include a CPU or some other memory. For the control logic construction, debugging slave systems is usually more challenging because you have to build it yourself. Master systems, of course, having their control logic already built into the FPGA, are very easy to debug, and often the debugging is minimal. Another common question is, should my system use a single FPGA or multiple FPGAs? Well, most applications need only one FPGA because the newest devices, of course, have very large density. But some require more pins than are available in a single package, or, again, more logic than they can possibly fit into the largest device. In those cases, the user should plan on building their application with multiple FPGAs and use a single data source for storing the bit streams of each FPGA. When this is done, a daisy chain always makes the most sense since it reduces the board routing and reduces system cost. So we'll be discussing daisy chains in a few minutes. I want to point out as well that your configuration user guide for your chosen device family will also show more possible daisy chain configurations than we're going to show you here in our discussion. Another common question we'll get is, which is the simplest configuration scheme to debug? Well, master, BPI, and SPI modes are the easiest to debug since their control logic is already included and verified. These modes also have the fewest pins versus parallel modes, which have the most pins to resolve. However, SPI and BPI modes may also be the least expensive of the simple configuration modes. So you might want to read up on all three if you're looking for just the simplest, fastest way to get it done and move on. Another question we get is, should I choose the lowest cost configuration solution? Well, to answer this question, we need to ask you a few questions yourself. First of all, do you have a spare non-volatile memory component in your system, such as a system memory, hard drive, or does your application support downloading a bit stream remotely? If so, then you may want to build your own slave configuration scheme that allows you to store your bit stream in one of these resources. But another question to ask is, can you consolidate your non-volatile memory required in your application? If so, the compression or consolidation may allow you to purchase a smaller memory component and save some money. Likewise, can your bitstream be stored with your application code? Your software code, that is. If you're building an embedded design, then you should consider having your embedded application stored with your FPGA's bitstream in a single memory device. And we'll talk a bit more about how some possible solutions that we offer in that realm as well. Another question is the fastest possible configuration time the more important consideration? Well, at the same frequency, parallel configuration schemes are inherently faster than serial modes. Of course, if you're configuring multiple FPGAs in a daisy chain, then your configuration time will be no longer. But there are a few things a user can do to speed up their configuration time. In the master configuration schemes, the configuration clock frequency can be increased. However, how much it can be increased will depend on the read specifications of the non-volatile memory component you're using. So if you can purchase a faster memory component, you may be able to increase your configuration speed. Likewise, since your FPGA's configuration clock will vary by speed grade, you should be able to increase your configuration speed by using a higher speed grade FPGA. If you have an external clock in your system that is faster, you may be able to configure it in a slave configuration scheme at a higher clock rate that way. As an FYI, note that if you want to configure an FPGA at a higher rate, you should take care to avoid any signal integrity issues. Many customers do not bother with this, and they end up having to debug their configuration process later on. Another question is, will the FPGA be loaded from a single configuration image or with multiple images? Well, if your application needs multiple images, there are some nice FPGA features to consider. The solution to this problem exists in Xilinx's newest FPGA families and is called multi-boot. This allows an FPGA to configure with different bit streams on whatever occasion the designer would like. One of the best examples of this is during a hardware-assisted test. In this scenario, the FPGA is loaded with a bit stream to perform the self-test, followed by another bit stream with the final application. The JTAG and slave configuration schemes are frequently used during debugging for this purpose just as well. Another frequently asked question is, what I/O voltages are required in the end application? Another common situation arises when a designer is planning on operating their FPGA at a voltage other than 3.3 volts. When this happens, the user needs to be aware that the memory component they may be interfacing to may require a voltage other than 3.3 volts. In this case, it is important that the designer be aware that the FPGA configuration pins are reserved and usually placed in a single I/O bank. Thus, depending on your configuration mode, that will require all the I/O pins in that bank to be compatible with a 3.3 volt device and may limit where you want to place your other I/O pins on your FPGA. So, plan your use of the bank pins associated with your dedicated configuration pins. Plan them a little carefully. The most common scenario customers are encountering is that the Virtex 6 is powered at 2.5 volts and needs to interface to a 3.3 volt SPI or BPI component. If that is the case with your design, you may want to consider using a Xilinx platform flash PROM. Also remember that other vendors are eventually going to be producing a compatible flash memory. So check the vendors you see listed here in this slide if you're using a SPI or a BPI configuration mode for Virtex 6 if you don't want to use a Xilinx platform flash device. Another question is, should the FPGA's I/O pins be pulled high via resistors during configuration? Well, it is important for all users to be aware that floating signal levels can be a problem in CMOS logic systems. The internal pull-up resistors included with each I/O pin generates a logic high level on each pin. Some customers choose to turn off the use of the pull-up resistors because it provides a current path to the I/O power rail in hot swap applications. So some customers pull down their I/O pins by using an external resistor. However, an external pull-up or pull-down resistor is then required on each I/O pin at some additional cost.